Right, cool. Today we're presented with the following integral. We need to integrate sine x over 3 plus sine squared x with respect to x. Now, well, when integrating, the first thing I look at, does the denominator differentiate to give something on the top or something of that nature? Well, sine squared x differentiates to 2 sine x cos x, which is obviously not a numerator. So the way we'd go about this is by a means of substitution. Now, the obvious substitution to have is u equals sine x. And I'll show you why this doesn't work. So let me just copy this for later. Alright, let's sub in u. Well, before we do that, let's differentiate du or u with respect to x. So we get cos x. Let's rearrange for dx. So we get 1 over cos x du. Right. And we know cos x is the same as x equals 1 over, so using the identity cos squared x plus sine squared x equals 1, rearrange for cos x, we get 1 minus sine squared x, which is 1 minus u squared. Right, let's do some substitution. So u plus 3 plus u squared multiplied by dx, which is 1 over 1 minus u squared du. Let's quickly combine our fraction. So we've got u over 3 plus u squared root 1 minus u squared du. Okay, can't simplify any further, so let's go straight to integrating. Now I'm going to be honest, this is nasty to integrate. So what we can conclude that sine x was not the optimal substitution. Now, we tried sine x, that didn't work. Now, let's use cos x. Cos x seems sensible. Differentiates to minus sine x, perhaps there's a link there. So let's go and deploy this strategy. So let u equal cos x du over dx equals minus sine x. We rearrange for dx, so we get minus 1 over sine x du. So dx equals minus 1 all over root 1 minus cos squared x, which is u squared du. Now let's follow this through. So u equals cos x. So sine x equals root 1 minus u squared or 3 plus 1 minus u squared. Dx equals minus 1 all over root 1 minus u squared du. Now let's start simplifying. So we know immediately that these two sets just cancel. So we're left with minus 1 4 minus u squared du. Alright, we've made a lot of progress now. This looks much easier to integrate. Let's factorize our denominator. So we've got 2 plus u, 2 minus u. Now we just have to partition our fraction using partials. So we've got 1 plus 2, 1 over 2 plus u, 2 minus u equals a over 2 plus u plus b over 2 minus u. If you times through by 2 plus u and 2 minus u, we have a times 2 minus u plus b 2 plus u. Let's expand and collect like terms. So we have 2a minus au plus 2b plus 2u. So what we can do, we can collect the u terms. So we have minus a and b, so we have b minus au. Then we've got, then we've got 2a plus 2b plus 2b, which can be rewritten as 2a plus b. So if we bring in our u, 0u plus 1 equals b minus au plus 2a plus b. Now let's compare coefficients using matrices. So we've got u and we've got 2, which is our constant. So we can say 0 equals b minus a. Now for a constant we have 2a plus b equals 1. So b equals a from our first line matrices, and then 2a plus b equals 1. We can substitute, we can replace b with a, so we've got 2 times 2a equals 1, 4a equals 1, a equals a quarter, meaning b must also be a quarter. So let's go back to our integral. So we've got minus a, which is a quarter, 2 plus u plus a quarter 2 minus u, and this times by minus, we've got minus quarter 2 plus u, and then minus quarter 2 minus u, minus 1. So if we expand the denominator, we've got 8 plus 4u minus 1, 8 minus 4u. Right, I forgot to mention we are still integrating with respect to u, so du. Right, now let's integrate each part. So here we've got minus a quarter ln 8 plus 4u. Is this correct? Quickly differentiate. We have on the inside we've got integrate 8 plus 4u, which is 4, multiplied by minus a quarter, then differentiate ln 8 plus 4u. We have 8 plus 4u, cancel, minus 1 for 8 for 4u. Yep, that's fine. Let's integrate this now. Our second term, minus 1 over 8 minus 4u. So we've got quarter ln 8 plus 4 minus 4u. And does that work? Yes, it does. And if we substitute, well, I think we can factorize, so we can take out minus a quarter ln 8 plus 4u plus ln 8 minus 4u. So minus ln 8 4u. Combine our ln terms, so we've got ln 8 plus 4u over 8 minus 4u, and then if we substitute our u back in, we have minus a quarter ln 8 plus 4, and u is cos x, so 8 plus cos 4 cos x over 8 minus 4 cos x. Well, that is our integration or integral complete. Thank you very much, guys. See you in the next